good.
Yeah.
How far did you get?
I got to like 20.
Okay, I stopped at 19.
Okay.
So I did 19, and that's where I stopped.
Me too. I did 19, and that's where I stopped also.
Okay. Sweet.
So.
Well, since you guys did that, Eddie, you didn't do it, and I didn't do it, right?
Yeah, I'm on number 11. Well, 13.
We can go through it.
Let's just talk through it, and I'll make notes.
Okay.
All right. I want to know if I got them right.
Me too.
So
And
that'd be good.
you guys are just doing the review questions that was in the lesson, right?
Yeah.
The links you gave me.
online, the text.
Yeah.
Yeah. Okay.
And we're okay. So with the exam, we're allowed to have a sheet of like a cheat sheet, right? One piece of paper, one-sided. Is that what it is?
I don't know.
Two-sided?
I haven't looked at the exam thing. I didn't know we had an exam until an hour ago.
Well,
when I looked online to do the prep assignment.
Let me see.
Oh.
It said something on there. I just want to make sure because I know we're allowed to have notes. But my question is it recorded? Because I've had tests where I had to be proctored. I have tests that it was recorded while I took the test, but I don't see anything like that. I think it's just you take it, right?
I think it's just based on like the honor code.
Right.
Yeah.
Take it. So
I just didn't want to miss something because everyone, like my economics class was videotaped, and then my accounting class I had to have it proctored. So.
Oh.
No, I think it's pretty simple.
Have you guys taken accounting yet?
No.
I don't have to take that for biology.
Oh, accounting, it cost me like $150 in proctored testing.
Really?
To do it. Yeah, it was horrible.
I think I have to do it.
Well, are you in Rexburg? Where are you?
I live in Orem.
Okay, so you can go to the BYU Testing Center and you don't have to pay for it.
Well, that's good.
Yeah. And if you live anywhere near where they do pathways, sometimes you can do it there also.
Okay.
That's cool.
Let's see.
All right. You guys, those that have gone through the questions, you guys just want to kind of explain, take turns with explaining why what you put and why or whatever?
You're allowed to have one side of notes. One side of a page for notes is what it says.
Okay.
So write really small.
And the TA did say and maybe I said this before, to specifically put the actual definition of the CLT and the large theorem, like word for word. Because she's like, you'll be asked basically word for word what it is.
Are we supposed to like type it in, or is it multiple choice?
Oh no, it's going to be multiple choice. But
okay.
She said you'll need to know the exact wording for those definitions. That's what she told me. So I don't know if they'll have options that are somewhat similar but different. Try to trick us. I don't know.
It might be like those quiz questions where they ask you to put in like a little segment of the sentence.
Oh yeah.
Something like that. That could be it, because she just said you need the exact wording. That's what she said.
All right, I'll start with number 1. You want to start?
Okay. You can start.
Okay. What is the name of the important statistical result that guarantees the sampling distribution of the mean will be normal if the sample size is large? And I put the CLT.
I put the central limit theorem too.
Okay.
What'd you put, Eddie?
CLT. Yeah.
Okay.
Right. Number 2 says, what is the name of the important statistical result that states that when the sample size is large, the sample mean will be close to the population mean? On that one I was confused. I put center/law of large numbers.
I put law of large numbers, and there was a reason for it. Let me see if I can find it where it said exactly those words, and that's probably what Catherine was talking about. What lesson was that one in? Was that in, oh, it was in 6.
Yeah.
Okay, so if it goes in 6, because I was back and forth on that one too,
Mm-hmm.
and that was the law, let's see.
of large numbers.
Okay, the law of large numbers in like page 6 of the lesson of that lesson, it says a large number states that a sample size is large, then the sample mean will typically be close to the population mean.
Totally.
So when you talk about large numbers, it's talking about population also, and it didn't say that in the central one.
Cool.
I agree that it goes with that.
Okay.
Because the whole idea of the law of large numbers is to help us get closer and closer to the mean, I think, the idea of the population, what they're going for.
Yeah.
Okay.
Sweet. You want to do 3, Eddie?
Sure. Which of the following variables is or are categorical? And I have for categorical was the toothpaste, and I think the third one is the same, isn't it?
I put 2 and 3.
I didn't put 3.
You didn't put 3?
No. The only reason I didn't is because categorical is like, you know, a jersey number that I guess in a phone number they said that they could do because no other person has your phone number and no other person on a team has your jersey number. But in age and years of randomly selected, there could be other cars in the parking lot the same year.
That's true. I didn't look up the definition, but
So,
if that's the definition, it's probably not 3.
like the numeric one, it was all numbers, but the ones that were like not used were like telephone numbers, jersey numbers, or license plate numbers that no one else has.
Those are not, or those are categorical.
Those are categorical, but if it's something that someone else can have, like a year card, like if I have a 2013 and there's like 5 other 2013s in the parking lot, that would be numerical.
Okay. Okay.
That's my opinion. So, is there an answer sheet to this?
No.
No.
I wish there were.
Me too.
We can do that little system at the end that we had before.
Okay,
Yeah.
yes. Okay, I'll do 4. The mean IQ test score in the United States is 100. 20 randomly selected statistics students took an IQ test, and the mean of their score was 112. Which of these two numbers is a parameter, and which is a statistics? I put the parameters 100, and the statistics 112.
That's what I put.
Okay.
Okay. Number 5. Rothman City has 4 distinct neighborhoods. The property values are very similar within each neighborhood, but they vary considerably from neighborhood to neighborhood. One neighborhood is very low or has very low property value, and another has extremely high property values. Property taxes are usually roughly proportional to the property values. What type of sample would we collect to gauge the residents' response to a proposed increase in property taxes? I put stratified sampling.
Me too. What about you, Eddie?
Yeah, same.
Okay.
Okay.
I'll read number 6.
Sweet.
When design experiments are conducted in public school systems, researchers typically choose a particular district and randomly select teachers of, say, 4th grade students in that district. The experiment is then conducted using all the students in the selected classes. Which type of sampling scheme is implemented? And I got convenience sample.
I put cluster.
I put stratified.
My first thought was stratified.
I'll say
help?
why I did cluster, and then we'll listen to why everyone else did. And that was in, was that in 3? I can't remember. No.
It's a 2.
It's 2.
Less than 2, yeah.
So, I'm trying to find it. Hold on. Okay, a cluster consists of taking all items in one or more randomly selected clusters or blocks. For example, all the accounts receivable items in a few randomly selected months. So this one, the reason I did it is because they randomly selected, say, 4th grade, is what it says.
Mm-hmm.
And they randomly select teachers of 4th grade. The experiment is then conducted using all the students in that selected class. So I'm trying to find the exact, I had it somewhere. Hold on. So a cluster is all items in one or more randomly selected cluster. And a convenience is one easily obtained in a less than systematic way. It is systematic because they chose one group.
Mm-hmm.
So then the stratified one was divides data into similar groups, and then they do a simple random sample. And this one says they didn't conduct it all the students, so it wasn't random.
Using all students in the selected classes.
A stratified is when
I can see why it's cluster sampling.
okay.
Yep, I think you're right.
What do you think, Eddie?
Well, I had convenience sample or cluster.
Okay.
But I'm not sure, like, why couldn't it not be convenience sample?
The reason it can't be convenience is it's easily obtained in a less than systematic way. And I think it was systematic because the researchers chose a particular district and randomly selected all 4th grade students. So the cluster is one or more randomly selected clusters. So that's one cluster of 4th grade students, and then they sampled all items in that cluster, not a simple random one. Like
Yeah, I think if it was convenience, it'd be like all the 4th graders in like the lunch area at the moment, because it'd be convenient for them to just do it at that point.
Huh. I think that makes sense.
I think it's tricky in how they word it.
It is. It is. But I agree with you that it's cluster.
Okay.
Yeah.
Cool.
Okay.
All right. I'll do 7. At a school fundraiser, the name of every person who attended was entered into a drawing. At the end of the evening, 6 names were selected to receive door prizes. Which type of sampling scheme was implemented? And I put the simple random sample.
I put that too.
Okay.
I'll read the next one. A special interest group is conducting a survey regarding wolves in Yellowstone National Park. To adequately gauge opinions on both sides of the political spectrum, the researchers took the list of registered Democrats and selected a simple random sample of 100 people. Then they took a list of registered Republicans and selected a simple random sample of 100 people. Which type of sampling scheme was implemented? I put stratified sampling.
Me too.
Okay.
Eddie, what'd you put?
Stratified sample.
Okay.
I'll read one.
Okay.
You can read 9.
Calculate the descriptive statistics of the amount spent in crosswords purchases. Give the mean, standard deviation, the 5-number summary of the data.
Okay. So I didn't know how to do the 5-number summary, but what do you guys get for the mean and standard deviation?
The mean I got 4.771.
Mm-hmm.
And the standard deviation I got 1.912.
Yeah, that's what I got.
The 5-number summary, if you go to, and I couldn't stay in that program because I didn't pay for it. I couldn't get it into my Hangouts. But if you get into that program, what is it called? I'm sorry. The
SPSS?
Yes.
Yeah.
And you have your, I can't remember the name of it, but it will say your minimum and your maximum.
Okay, let's see. I'm going to try doing it. Did you click on Explore, Frequencies, Q plots?
I did Explore. Here, let me look. I'm trying to see where I exactly did it. Hmm. I don't know if I did analyze, descriptive, statistics, and then explore.
Yeah. Mhm.
And then, okay, you get to your descriptives. On your descriptives, it'll say minimum and maximum, right? Like one on top of the other.
When you click on explore.
Yeah, if you do analyze and then select descriptive statistics and then you hit explore,
Mhm.
and then you'll choose, what did it say? They wanted to calculate the
Yeah.
amount. So choose the amount and then hit OK.
Okay.
Um,
Oh.
okay.
That's it?
Yeah, did you see the descriptives?
Yes, I did.
Okay, so you have your minimum and your maximum,
Mhm.
and that will be 2 parts. That's your first and your last of that 5-point summary.
Okay, I got that right. And then I got the median, which is the 5.15, right?
Which is your Q2.
Uh-huh.
And then Q1 and Q3, if you go down, I couldn't remember where it was. If you go down, I think it's, go down, like, scroll down even further, and it should have, there's like more than 5, but then on the next line, there's only 3 showing. And it's on a graph that's like horizontal.
I only have one graph.
Okay, let's try another one then, with that same information.
Mhm.
Let's go into.
What were your other 2 numbers? I have 0.84, then I'm missing a number, then I have 5.15. I'm missing a number, and then 10.45.
Okay, so your minimum is a 0.84.
Mhm.
Your maximum is a 10.45. And then Q1 is 3.420.
Uh-huh.
Q2 is 5.150.
Uh-huh.
Q3 is 5.610.
610. Okay, I'm gonna see if I can find those numbers here.
Because I'm trying to find the other, how you get into it. I had it all pulled up. I was hoping that I could keep it up, but it wouldn't let me get into Google Hangouts with it.
Yeah. I have it open on mine.
I'm getting into it now.
5.15. 3.2. Yeah, my only problem is finding the Q1 and Q3.
Yeah, I'm trying. If you go into, I'm trying to find the other. What's the other tab that you can go into that's not to find, not analyze? What was the other one?
Graphs.
No, because that one would just give you that one.
You can do frequencies, descriptive statistics and frequencies.
Is it percentiles that you need to go into?
Oh yeah, I remember we
Yes.
did percentiles.
Go into percentiles.
What was that? Let's see.
I think it's analyze, descriptive, explore, and then statistics, I believe.
Statistics. Oh yeah, percentiles.
So go into percentiles.
Oh, okay. Let's see. Analyze, explore, statistics.
And then the very bottom is just percentiles. And then I think if you hit OK, it'll pull up your Q1, Q2, Q3.
Oh yeah.
Okay, so at the very, see a horizontal one, and then there's only 3 options on the very bottom line of it?
Yes.
And is it those numbers, the 3.420?
It is.
Okay.
Oh, okay. That makes sense. So you click on percentiles.
So your descriptive takes care of your minimum and maximum, but it doesn't give you Q1, Q2, and Q3 until you do percentage.
Okay, when you guys were doing that, getting into your 5-point, is this for your 5-point summary?
Yes.
Yeah, it is.
Okay. Can you just walk through the steps in SPSS where you went to?
Okay, ready?
Yep.
So go into your analyze.
Uh-huh.
Then you go into descriptive statistics. And then you go into explore.
Yeah.
And that's when you're going to choose what you're doing, which in this one was the amount spent. and then you hit the arrow so it makes it go over, and you hit. Then you go to statistics, right, Catherine?
Yeah, statistics.
Statistics. And then when you get statistics, it pulls up other options, and you choose percentile. Catherine, did you have to unclick something at the top, too?
No, I just left it clicked.
Okay. All right.
Yeah.
And then when you hit percentile, it'll add that graph or chart, or it's not a graph, a chart to the end of that. Where I like how it just adds on top of it, all of it.
Yeah, it's nice. It just keeps on adding to your open window already.
Yeah.
which is
And
really-
Marjorie, it's like horizontal. Hey, can you share your screen, Catherine, and show her what it looks like? Because it was confusing to me, because it
Yeah.
has more than 5 across, but you're only looking for the 3 at the bottom.
Here you go.
My laptop needed to restart, so I'm trying to get into it on my computer, on
Okay.
the desktop.
Can you see my screen?
Yeah.
Okay. So where is it? You were talking about the percentiles right here.
It's just the bottom 3 numbers.
Yeah,
Okay.
just these.
And that would be your Q1, Q2, and Q3.
And then your minimum and maximum are just right here. So,
Okay.
good?
Yeah.
Okay.
Thank you for doing that, ladies.
Yeah, that helped me a lot too, so good.
It's just so good to go through it so that in the exam we're like comfortable going into analyze, going into descriptive, just
Yeah,
doing it.
Yeah.
it's true.
Okay. Number 10.
And then that's just a histogram that you do from the same program.
Yeah, that was easy.
Yeah.
I kept mine open just in case we have to click on the histogram, so I know what it looks like.
Okay.
Okay, so let's do 11.
Okay. Jessica Meir and her research team measured the body temperatures of a sample of diving elephant seals. A thermistor was placed at a specific location on the seal to measure its body temperature. The body temperature of seals tends to decrease as they dive. The researchers estimated the typical body temperature of each seal at the time they initiate a dive and called this a representative temperature of the seal. They were placed at the hepatic sinus of 4 of the seals, and it names them. The seal's body temperature at the start of the dive was calculated to be. Complete the following table and answer 11 through 14 below. And 11 says, what is the value of the number that goes in the position marked with an A for the table above? And I put negative 0.165.
That's what I got.
Okay.
Okay. Did you get that, Eddie?
Yep.
Okay. For 12, it says, what is the value of the number that goes in the position marked with a B in the table above? And I got 0.681.
Yes.
Yep.
Okay. Do you know how to get these, Marge?
I'm getting there. Yeah, I actually met on Saturday with my brother and did this whole table with him and kind of just reviewed it. So I'm feeling a lot better with it.
Okay. Cool.
And it's not hard. It's just knowing what to do for each one. And
Yeah.
it's really pretty simple.
Okay.
Let's see.
13 says, what quantity is equal to the sum of the numbers in the square deviations column?
I put D.
Yeah, I put D. I put none of them correct because the mean was the 38.075. The standard deviation was 0.715, and the variance was 0.511.
And the sum of that was 1.534.
Yeah.
So I put none, yeah.
Okay.
All right. 14, Donna?
What is the standard deviation of these temperatures? And it's 0.715.
Okay, I got that.
Okay.
And 15 says true or false. Understand?
Deviations.
Yeah? What'd you say, Eddie?
How'd you get number 14?
Okay, so you add up the standard deviations column, and then you divide that by the amount of options minus 1. So it's 1.534 divided by 3. And that gives you the variance, that's 0.511. And then to get the standard deviation, you take the square root of 0.511, and you get 0.715.
It's just a lot of steps.
It is. Does that make sense?
I'll go over it later, but so you just added up all the x minus x bar?
X minus...
So the standard deviation, all you're going to do is the square root of the deviation from the mean column.
Deviation from the mean. Okay, just square root all the mean of that?
No.
Yes. No. So like the answer to A is the negative 0.165, and just times it times 0.165. So your
standard deviation for that one is 0.027. And then you square each of the other ones in the deviation from the mean column, and you get 0.027, 0.681, 0.819, and 0.007. And you add those up, and you divide them by the amount of options minus 1. So it's 3. And then you square root that answer that you get.
But did you understand how you got your squared deviation? Because all you're doing is squaring the deviation from the means.
Yeah.
And that's what you get for square deviations, right?
Yes.
And then you said you add them all up,
Mhm.
Yes.
and then you subtract it from 1.
No, you add up that column, which comes to 1.53, and then on the seal side where it has Bodley, Roberta, Larry, and Pear, whatever, there's 4 subjects right there. So you would take 4, and for some reason you always minus 1. So now you have 3. So you would take the sum of the square deviation over 3.
Okay. All right, I got it now.
And that would give you
0.511.
the 0.511, and then you
take the square root of that, and that's
Yeah.
your standard deviation.
it's just a lot of steps to get one number, it seems like.
Yeah.
Okay.
Okay.
Perfect. Thank you.
Put that on your cheat sheet, because to me it's like that's a really easy one to mess up because there's a lot of steps to it.
Yeah.
Yeah.
And there definitely will be a question like that.
I'm sure. Okay. 15. True or false? Under certain conditions, the standard deviation can be negative. I'm pretty sure that's false.
Yeah, because isn't standard deviation just like 0 to 1 or 2 or 3? We never talked about any negative.
Yeah.
Okay, I thought so too, but I wasn't positive.
Okay. Cool. You want to read 16, Eddie?
Yeah. In the same study, the researchers placed thermistors, temperature sensors, in the 3 seals named Chick, Starburst, and Patty, near their spinal cord and brain in the extradural vein. They placed thermistors in 6 other seals named Sir Richard, Jerry, Samu, Nut, Jonas, and Butler in their aorta. Their large artery in the body. Finally, they placed thermistors in 4 other seals named Bodil, Roberta, Larry, and Pear, and their hepatic thymus. The results from the study are summarized in the table below. Which location resulted in the most consistent temperature measurements from one field to another and justify your answer.
Okay.
I guessed on this one, so I'm not even sure.
I put extradural
Me too.
because it has the lowest standard deviation.
Me too. So we're
Okay.
thinking the same. I
Sweet.
looked at that and I'm like, I don't know, but the lowest standard deviation is the extradural one.
Yeah, so. Cool.
Sounds good to me.
All right.
Which
can-
little? Oh,
Can we skip that one? The 17, because that's in your own words one.
Oh, yeah, I just wrote down the exact definition.
Yeah.
It's the measure of spread of distributions.
okay.
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 We're on 18, then?
The number of hours students spent studying for an exam were recorded. The data are represented by the box plot below. Use the box plot to answer questions 18 through 19. 18, give the 5-number summary of this data.
I put the minimum was 2 and the maximum was 12.
Yeah.
Q1 was 4, Q2 was 6, and Q3 was 8.
That's what I put.
Okay.
I didn't, so the thing, since the 6 is there, you see a little circle with the 6?
Yeah.
I put 14 as the maximum, but then I changed it to 12. But
I think 6 is just showing that that's the median.
I think the median is 6, right?
Right. Yeah, and I think that's what that thing off to the side is.
Oh.
The
Okay.
median is 6.
Ah, okay. That makes sense.
Oh, that's what it is. So minimum 2, maximum of 12, right?
Yeah. So the Q1, Q2, and Q3 are always in that box, and then the minimum, maximum, they call those whiskers.
Yeah.
And so you just go to where that's plotted. You don't go beyond it.
Perfect. Okay.
And then it says, what percentage of the data lies between 4 hours and 8 hours? I put 50%.
I put that too.
Okay.
Yeah.
Because each one would be 25 to get, well, yeah. Between,
Yeah.
Okay,
Yes, because the whole is 100%.
right.
And that box is always, the box is always 50%, even if the box is like
Right.
really long or something like that.
Yeah. Sweet.
Do you guys want to read all this or just go? That's as far as you guys all went.
Yeah,
Right.
we have all stopped here, so we should probably do all of these just in case.
Okay.
Okay.
Well, we have to do them anyways. These are the exact same as the quiz questions, so.
Are they? Did you already open up the homework or the?
No, when you opened up this, it said these questions are the exact same as your group quiz.
Sweet. I didn't read that.
Awesome. So then we can check our work to make sure that we're
Yeah.
not learning wrong. Okay. An observation from a normally distributed population is considered unusual if it is more than 2 standard deviations away from the mean. There are several contaminants that can harm a city's water supply. Nitrate concentrations above 10 parts per million are considered a health risk for infants less than 6 months of age. The city of Rexburg reports that the nitrate concentration in the city's drinking water supply is between 1.59 and 2.52 parts per million, and values outside of this range are unusual. We will assume that 1.59 is a value of mu minus 2 mean, right?
Mhm. Well,
And
I think U is the mean, and
Yes.
2 is the thing is the standard deviation.
right, so the mean minus 2 standard deviation. And the mu, which is the mean, plus 2 standard deviation is equal to 2.52 parts per million. It is reasonable to assume that the measured nitrate concentration is normally distributed. Use the information to answer questions 20 through 22. Estimate the mean of the measured nitrate concentration in Rexburg's drinking water.
Is it just the mean?
Is it 1.59 plus 2.52 divided by 2?
I would think so because those are the only numbers they give you.
Yeah, this question sucks.
Yes.
Okay, I think that's probably our best bet.
Let's try that and see.
I'm locating my calculator.
Do you get 2.055?
2.055 is what I got.
Okay, so I got 2. And then it says estimate the standard deviation of the measured nitrate.
That's like the standard deviation.
So you said the mean was 2.055. And then, so standard deviation is, one standard deviation is that plus,
Plus 2 and one's minus 2, but
and minus 2. So it's 4.055 and 0.055. Huh.
see, that's not the standard deviation because they said that their standard deviation was considered usual, right?
Mm-hmm. It's considered normal. So is the standard deviation 4.055? Or if it is more than 2 standard deviations, there are several contaminants that can harm Sane's water. Health risk. I don't know, actually.
I don't know, I'm trying to read the question over and over again to see what I'm missing.
Mean of the measured nitrate.
I have no idea, honestly.
I'm going to look through one of our lessons and see if it has anything like that really quick.
Okay.
When we did mean maybe in 4?
Well, if we just came up with a couple, I don't know, thoughts for it, we could always try.
Yeah, let's see. I'm looking at the little summaries they have for each lesson.
Would the formula be like 2.055 for the mean minus
Yes.
2 and standard deviation?
But we're trying to find the standard deviation, so what's the formula for that?
That'll be
Oh.
okay.
The standard deviation can be our x.
Yeah.
So it'd be 2.055 minus 2 standard deviation. And then,
Equals.
so
And you have
you
to do
do-
one to the side.
2.055 equals 2 standard deviation. You divide it by 2. So I would say standard deviation is 1.0275.
Estimate the standard deviation of measured nitrate content. How did you figure that out? So you plugged in the 2.055 for your mean, right?
Yeah, so I just did what Eddie said. So I put 2.055 minus 2 times the standard deviation, and then I added the 2 standard deviation to the other side. And so it was 2.055 equals 2 times the standard deviation, and I divided that by 2. So the standard deviation is left alone, and then you divide 2.055 divided by 2,
Yeah.
and you get 1.0275.
1.0275?
Mm-hmm.
Okay.
Is that what you were saying, Eddie?
Yeah. I still haven't gotten like the steps to it. But you said
Okay.
you said we subtract to put on the other side, so you just get -2. X
No,
standard
it's
deviation.
positive because it's originally it's negative, or I guess whichever one you use.
Yeah, but it'll be
But
different, right?
yeah, I just used the first one, the mean, 2.055 minus 2 times the standard deviation. And then I divide it by 2. So it could either be positive or negative of this answer then, is what I'm thinking. Maybe.
Let's see.
I honestly have no idea.
So I don't know because I got 0.2325.
That's probably because you did it the other way.
So what I did, I moved over the 2.055 to the right side where the 1.59 is.
Well, 1.59.
Because u minus 2a or u minus 2 standard deviation equals 1.59.
Does it?
That's what the problem says.
Is between 1.59 and 2.52. So are you saying that the u minus this mean minus the 2 times standard deviation is equal to 1.59 and the mean plus the 2 times standard deviation is equal to 2.52?
Yeah.
Huh. That could be possible, but I don't know.
But is that the mean? Because that wouldn't be the mean. That would be just the between, like the mean is finding the middle, like the average. I don't know.
Well, our mean is within that. Our mean is 2.055. In between. Okay.
Right.
I
don't know, you guys.
have no idea. Are there any questions like this in the homework? Or in the textbook? What lesson is this?
Not that I saw.
I've never read the textbook. This is a tricky question.
So I'm looking in the textbook on chapter 4. Section 3.2, and it's talking about finding the standard deviation of a discrete random variable. And it has a table again, but I don't know if that's the right way to do it or not.
Let's see. I'm gonna. Let's see if there's anything in lesson 5. Curves. I don't think we've ever been asked a question that's been worded that way.
Yeah, that's a hard one.
Oh, actually, I think I remember something where in a video they said that if it's between, you find both the standard deviations and then you subtract them from each other, you average them out.
What lesson do you think this is from? Or that might have been?
No, I'm looking at lesson 5, 5. And there's nothing in here like that. Let's see.
It would have been really good to try to get the TA to meet with us today. Like if she had, it would be for those that she's meeting with so soon to the exam.
Yeah.
Going over this.
Okay, let's see. Because they're density curves.
Yeah, standard deviation on that one, I feel like it has to be 0.2325 because if you plug it in,
Can you
it
put
should
this?
work.
Can you put this into SPSS with those two numbers, and it'll give you the standard deviation?
What would you use? Just going into the...
Like if you went to SPSS and just put in the 1.59 and the 2.52, and then did the analyze descriptive statistics and explore, would it give you and shows that column?
I can try. Let's see. Let's try. So it's 1.59 and 2.52. 2.52. Okay. So analyze frequencies. About standard deviation, right?
Yeah.
Okay. So I'm doing that right now. And it gave me 0.65761.
So not what we got. But we're supposed to have -2 or +2 of the standard deviation.
What did you get first, Eddie?
0.2325.
2.5. Okay, let's try that with the other side, where it's 2.055 plus 2 sigma equals, what is it? 2.52. 2, so subtract minus 2.055. 0.65 divided by 2. Oh, it's the exact same. If you do either equation, which either one, it's still 0.2325.
And that
you
would be good.
positive.
Okay, we can put that as the answer. Doesn't hurt.
What was the answer to that one?
0.2325.
And you did that by doing the 2.055 minus the mean and plus the mean on each side?
Yeah, I did both of them right now. The one with the minus using 1.59, the plus using 2.52. And I got 0.2325 for both of them. I don't know.
I don't know, maybe when we do the homework they can at least tell if it's right or wrong.
We'll find out.
Yeah. All right, 22. Between what two measured nitrate concentrations do approximately 68% of the data values lie?
Okay. 2.055 plus. So it's just the mean plus the 0.2325 and then minus, right?
I don't know. This one has me completely confused.
Between what two measured nitrate concentrates do approximately 65%?
2.75 and then...
Wouldn't that be the 1.59 and 2.52?
No. I don't think so. I got... Since we had the mean as 2.055, I added 0.2325, so I got 2.2871, and then I got 1.8225 as the other side. So
Yeah.
I think those are the two numbers.
So you took, for the between the two measures, you took the mean and subtracted it by the standard deviation?
Uh-huh.
And then
then
you
I
just,
added it on the other side.
because you just go from the mean and you go to the 68 and then to the 68
Yeah.
from that mean right there.
Okay, let me see. So it's 2.055 plus 0.2325?
Mm-hmm.
So that's 2.29 or 2, sorry, we do 3.
288.
288. And then the next one is a 2.055 minus 0.2325.
Yeah.
Okay.
Makes sense.
Okay.
Hopefully that's right.
I know if not, then like I don't
Because
even
I am
know.
so confused.
Okay.
What
Okay.
is the mean of the standard deviation of the standard normal deviation? To do, let's see.
What is the mean and standard deviation of the standard normal distribution?
What is that? What does it mean? So do we take that standard deviation? Ugh.
Isn't it? The mean is 0.0 or 2.055. 2.055, and the standard distribution is the 2.055 divided by something. Divided by.
1, 2, 3.
Standard distribution, normal distribution.
Is the number minus the mean over standard distribution. No, it's c-square. Over the square root of samples. I have no idea. I think they're the exact same that we found the previous questions.
So I think that the standard deviation is the 0.465. Yeah, it's 0.465, I think.
And how did you figure that out?
0.465 for 23.
Yeah. Well, the thing is, like, 'cause on the
Is that because you added up the 0.2325 times 2?
so you do the 2.055, which is the mean, and you subtract the 1.59. That should be your deviation for the first, for the usual. Because in the statement it says, for the unusual part, it's more than 2 standard deviations away from the mean. On the first paragraph.
Could we be using the same table that we did for question 16?
So if we created a table and then plugged in all the numbers,
Yeah, because I'm looking at it, and like I'm going through our lessons. I'm like, I don't see anything like this. But if you took like a sample size would be 1.59, another sample size could be 2.52, and then you can find the mean from there, which is taking those two, adding them together, dividing by 2, and then subtracting that number to find the deviation from the mean. I don't even know, because I'm looking all through our book and I don't see anything like this.
Yeah, I have no idea. Copy. I'm looking through Google to see if there's like any questions just like this.
I'm wondering if Quizlet or something would. I've used Quizlet and Khan for some stuff, Khan Academy.
Do you want to go on to the next group, that next question, and then come back to this one?
Yeah, probably. I wish they gave us like the answers, honestly.
I wonder if I'm gonna. All she'll say is no, but I'm gonna go ahead and ask if the teacher or the TA, I don't know, maybe they could post a little video or steps for these questions or something like that, because we could.
Or on our lesson thing, they have a questions and concerns. You can comment on that and ask if she can help us out with this 20 to 23.
Yeah, because I'm completely confused. I don't even know where to start. That's the problem. I'm looking at it and I'm like, I don't know if this should be in a table. I don't know if this should be in SPSS. I don't know.
I'll go ahead and after we're done, I'll just copy this section and say, is there any way you can walk us through these steps? We were having a really hard time in our meeting. And I'd be surprised if she says no way. So.
I'm going to post it right now, so maybe
Okay.
she'll do it as
Yeah, good call.
we are.
Because maybe by the time we were to the quiz or something, she might get to it or something.
So the actual teacher, one of the meetings that we had, I said it was a great meeting, but still confused. She actually sent me an email saying, if whatever you're confused about, let me know. I'll be glad to help. And she said no one's asking her direct questions. They're all going to the TA. So the teacher might be one who we can actually go to also, and not just the TA.
Maybe post it and let's email it to her. I know
Yeah.
she seems like she's longing for people to
Yes.
communicate with her.
I'm just posted it.
Thank you.
Okay.
Let's go on to the next section.
I agree, because that one's making me have a headache.
You know
Okay.
what I was realizing?
What?
Back to the last one. It just says, like, where is the 68%? And since the first paragraph on it says it's considered unusual to be more than 2 standard deviations away, then it would be usual to be 1 standard deviation away. So I don't know if you know what I'm saying, but I think that means, like, instead of doing the mean minus 2 standard deviation equals 1.59, for a usual or 68%, it would be U minus 1 standard deviation equals 1.59.
I don't know, Eddie.
Yeah, I don't even know.
Okay.
But if you have any inspirational thoughts on that, you let it, if anything. I don't know. I need to walk it through with somebody.
20
Yeah.
to 23 is what
We'll
we
do the quiz.
Okay.
Hopefully she responds sometime soon.
So I'll keep an eye out on that board also, because I'm sure she'll just post it there.
Mhm. Okay.
Or maybe
Doing
I'll make a comment to it saying, yes, I need help too. Maybe if we all go on there and she sees lots of people are having problems, maybe they'll address it.
Yeah, hopefully.
Okay.
Maybe someone that understands it can answer it too.
Yes, yeah. There's always that one person in class that gets it, right?
Yeah.
Okay, so let's go on. It says the admission committee for most Masters of Business Administration and BA programs require the graduation management admission test as part of the application for new students. It has been shown that the scores on the GMAT are normally distributed with a mean of 542.3 and a standard deviation of 120.54. The minimum GMAT score required for admissions to the MACC program in the School of Accountancy at BYU is 500, but is rare for students with scores less than 600 to be admitted. Use the information to answer questions 24 for 32. That was a lot of information.
Okay.
Yeah. So I have a question. Like the MACC program in the school accounting at BYU is 500. Is that considered the population then? I'm just assuming there's going to be a
That's
question.
a score. Let's see.
I don't think there's anything on population here.
No.
But is the rare students is the score less?
Yeah, it's just a
Okay,
score.
that's just the score.
Mm-hmm.
Because it's saying that let's see, their minimum requirement is 500, but it's rare for students who score less than 600 to be admitted.
Yeah, it's just a score.
Yeah.
Okay.
All right. What is the probability that a randomly selected student will score above a 542? So, is this when we would put it into the applet, figure out the z-score for it, and then put it into the applet?
I think we used the bell curve, the 68, 95, 99.7,
Yeah.
right?
Well, I know z-scores a lot of times are for probability questions.
That it was with the mean of 542. The probability that a randomly selected student will score above 542.3 on the GMAT. Wow. What would you plug into the applet if you did?
Well, you'd have to find the z-score for it. And probably random selected.
Oh, yeah, I see what you're saying.
Score.
So
And I think we would just do the simple z-score, the first one, because a randomly selected student is just talking about one, like an individual. So we would do the first z-score, just the value minus the mean over the standard deviation. This is total guess, but that's what I'm guessing. Because I really was learning that whenever it's just about a single person or a single object, then you do the simple z-score, and then you do the second, more complicated one if it's talking about a mass of people, like a large.
yeah, you're probably right. I'm going to plug that in the applet.
So what did you put for a formula?
Okay, so the value.
I did 1 minus 542.3 divided by 120.54. And I got negative 4.491.
What's the applet coming up with?
I need to click on the right sections.
I know. I need to bring up that applet for the tip. Just have it up. Because I always have to go in and find it.
4.49. I have it's a really small number.
Well, I mean, our z-score was -4, so.
Yeah.
Does this one give us our standard deviation or no?
It does. It's
Okay.
120.54.
It's in the middle. So what did it say? Like the area? Is it just?
It's 0.0000317.
Oh, I know what it is.
What is it?
What do you think, Eddie?
This is 50%.
Why?
Because if you got the mean of 542.3, right in the middle, and it says what is the probability that a randomly selected student will score above a 542.3, so that's 50%. 50% will score above the mean, and 50% will score below the mean.
But I think you're thinking that the mean is the same as the median. The median is what's in the middle.
And the mean's average. They said not to use average. So
I don't think the mean and the median are the same.
I think, well, for this one, since it's the mean, it is in the middle because it's a score.
I don't know.
So I'm looking at lesson 6, the practice assignment or preparation assignment. I'm looking at number 8, and it's kind of asking the same thing. So I'm kind of trying to look at it and how we came about our score.
So lesson 6,
Yeah.
number 8. Okay, what is the shape distribution mean?
I don't know. I just really think we somehow use this applet because it keeps asking below and above.
What is probably the random select student will score above?
Or we could try the more complicated z-score and see if that would give us a better z-score to plug in to give us more of a legit area.
It's talking about probability, right?
Because if you want to get the z-score for that, you would have to put in the formula of 542.3 minus 542.3 over the standard deviation of 120.54.
I think in this one, we're talking about the 68.
Yes, I think so too.
I don't think we need to do anything with the z-score.
I think it's going to be in that 68. Because it's right in the middle, right?
Let's see. So if it's 542.3, so you want to know who's going to be greater, so you take half of the 68. So 34 plus half of the 95 minus 68 divided by 2, 13.5 plus 2.35, so 2.35. I'd say 49.85.
Percent?
Can you show us your piece of paper if you're confident enough to show us what you did?
Well, I didn't write anything down.
Okay.
So I just did the little thing where it's 68 in the middle, then it goes 95, then 99.7, you know? And so I put 542 at the middle, and then I took half of 68, which is 34, and then I subtracted 95 from the 68, and then you get 27, so you divide that by 2, and I got 13.5. And then I took 99.7 minus 95, and I got 4.7. And I divided that by 2, and I got 2.35. And I added all those up, and I got 49.85. I don't know, it might be 50%. I honestly, have no idea. I'm, so lost.
Okay.
Let's put 49.85 and see whatever they... Do you think it's 50%, Eddie?
Yeah.
You're still thinking that?
Well, you can round it, so it wouldn't be 50%.
It does round to 50%. I mean,
Well, we can definitely try it.
yeah.
What would you do number 25, for example?
A random student score above 600 on the GMAT. I don't know, maybe we are doing Z-scores.
Yeah, because it's asking a lot of questions.
That's
for
my
just
only
percent.
thought is that because they keep asking for below, above, stuff like
And then
that.
then you're going to get into the 10th percentile and 90th percentile and the first quartile and the third quartile.
The z-score will be 0.
For what?
Number 24.
It'd be 0.00000317. That's what I got.
If you do 542 minus 0.3 minus 542.3 divided by 120.54?
No. For 24, you would do 1 minus 542.3 divided by 120.54 to get the z-score. Actually,
The z-score is
Oh.
the.
oh, you are right, Eddie. It is 0.
So how did you do that? The z-score, you have to do minus the one. Oh, hold on.
You want to
1
plug
minus
Wait.
542.
I'm
That'll
sure a
be
lot
the-
more people than 0 are gonna
Yeah.
score above 600% though.
here, but it would be the z-score of 0. You plug it into the graph,
And you
and
get
it'll be in the
50%?
middle.
Ah.
And the
Ah.
people who score higher than that will be the 50%.
So 24 is 0.5 then.
Okay, so 0.5. So I have a question for you. The formula for the z-score is x minus
Mu.
mu over the standard deviation.
Yeah.
What's x?
Is the
X.
mean. Oh. But we didn't do it that way. Isn't it the 542.3?
The
Uh-huh.
mean is, that's what mu is though. The u, so what are we subtracting from the mean?
Oh,
Because the
yeah.
standard deviation is 120.54.
This is what it would be. It'd be 542.3, which is what they're giving you, right? You want to see what's above 542.3. So you put 542.3 minus 542.3, because that's your mean.
I got it, guys.
What is
Over
it?
Okay, so are we talking about number 25 right now or 24?
24.
Okay, so 24 is 0.5 if we're doing it the way that Eddie was saying. So it's, so since you do that a randomly selected student will score above 542.3, so you do 542.3 minus 542.3 divided by 120.54 and you get 0. So you plug that in and you click on the right? So you get 0.5. So for number 25, you do 600 minus 542.3 divided by 120.54,
Yeah.
and then you get the z-score of 0.4786. So you plug that in and you click on the below, which is the left, and I got 0.3160. I think you're right, Eddie.
What was the answer you got? 3?
0.3160.
I don't know about 24 because I didn't know you would subtract the mean from the mean.
Because it says the score that they give you is 542.3.
The scores are normally distributed with the mean in the standard. The minimum score required for it.
Actually, I don't even know anymore. I don't know. We should just try it, and if it doesn't work, then we can do something else. Figure it out.
And what you
Yeah.
get for 25?
For 25, I got 0.316.
How did you get that?
I did 600 minus the 542.3
Uh-huh.
divided by 120.54.
Uh-huh.
And that gives you the z-score. So I plugged in the 0.4786 into the applet.
Did you highlight both sides?
No,
on the
it
left?
just says below 600.
Yeah, so there'll be everything to the left.
So the middle and the left.
Yeah, so that's everything below, right?
I don't know. Is it? I just.
Yeah, if it's probably a randomly selected student who will score below. So yeah, it's the middle because that last line is anything above that would be 600. So anything below that line is below 600.
Okay. So then it would be 0.684.
Yeah.
Okay.
I'm still having a problem with 24. I think that's wrong, but we'll see.
Yeah. Well,
Okay.
we can always
Work it when we
try
come
it
to it.
again. Sucks. This really sucks.
Yes.
I don't know, I think we're just overthinking it on number 24.
Okay,
Because
so
we
let's
did
just
26.
We'll find out.
yeah.
The second-
Let's just go to 26.
Yeah. I
Okay.
need to leave at 2:30, so I want to try to get the.
Okay, let's go.
We'll see.
Okay,
let's go.
26. What is the probability that a randomly selected student will score 600 or above on the GMAT? So you do the 600 minus 542.3 over 120.54. Is that right?
Yes. So you just click on the right section since we already did all the math.
Okay.
So it'd be 0.316, right?
Uh-huh.
Okay.
Say that again. 0.0.
0.316.
316.
Okay.
So then you just put the 10th percentile on the area, right?
What do you mean?
For number 27,
Uh-huh.
where it says find the GMAT score that corresponds to the 10th percentile, that just goes in the area, right? You put 0.10.
I don't know. Do we?
Yeah.
Yeah.
This
So I don't have my app lit up.
0.1. So you get, what is the question asking? Is
It's just a Z. What's the Z score for that?
negative 1.282.
If you want to get the 10th percentile, you highlight only the middle section.
Yeah.
And you put 0.10.
Only the
0.10.
middle section, and then you do 0.10.
Yeah.
Yeah, so it's 0.6827.
Oh.
Is that what you have?
0.126.
0.126, yeah.
Where had it? Oh, let's see. Hold on.
126.
Yes, 0.126. Okay. And then the same thing when you put in the 90, right?
Yeah, you do 0.9.
Mhm.
In the area.
At least we know if we're doing this completely wrong, eventually.
And that one you got 1.645.
Uh-huh.
So for 27, you get 1.26 equals x minus 542.3
What?
over
What?
1.54. Did you find the score, right?
What did find the score? Oh.
Oh, that's
you
more.
do- So you do 0.126 minus
Equals
or equals?
x minus 542.3
Uh-huh.
over 120.54.
Is all of that over or just the x minus 542.3?
Just x over the minus 542.3.
Okay, so multiply 120.54. Right. So you get 1.5804. Did you get 543.88?
I got 557.
542.
557.49.
How'd you get 557? So what you do is you multiply by 120.54 to get rid of the denominator. You multiply that times 0.126. And you get 1.58004 is equal to x minus 542.3. And then you add the 542 to the other side. And you get x equals 543.88. What'd you do, Eddie?
So I did 542.3 plus 120.54 parentheses 0.126.
Wait, why'd you add it?
because you move the negative 542.3 to the other side.
You can't do that because it's in a fraction. If it was multiplication, you would be able to, but it's negative. It's positive or negative.
Yeah, that's why you have the 0.126 parenthesis 120.54. Oh, sorry, I think I put that backwards actually.
So the correct math would be to multiply the 120.54 to the other side to get rid of the denominator, and then add the 542.3. Because since it's x minus the number, you can't get rid of it because you don't know what x is. So you have to keep it together.
Okay, so this is, well, we have 1.26 on one side, right? And
Yeah,
then
point.
it over 120.54, you multiply both sides, right?
Yeah, you multiply both sides by the 120.54.
So
So
you
on
have
one of
0.5,
the, huh?
sorry, so you have 120.54 times 0.126 on one
Uh-huh.
and x minus 542.3 on the other side, right?
Uh-huh. Yeah.
Then you move the 542.3 to the other side, so you add
You
542.
have to multiply the 120.54 times 0.126 first.
Yeah, well, that's already on the other side. Because
Yeah, yeah.
1.54 cancels out the other 120.54.
Yeah. So you have 1.58004 is equal to x minus 542.3, and you add the 542.3 to the 1.58804, and you get 543.88.
That's so weird. Why do we have different numbers?
I think it's because you need to do the math in the right order, or else it doesn't work.
Did you do 120.54 times 0.126?
Yeah.
And what did you get?
120.54 times 0.1. I got. Oh, you know what? You're right. I did 12.54, not 120.54.
Okay. I was like, what?
Okay, so you're doing the 120.54 times 1.26 to get rid of the denominator, right?
Yeah. So did you get 557.488?
Yeah.
Okay. Sorry. My thing is.
120. Oh, I did 102. Oh my gosh, we're just making math errors.
I know. I think I'm just done with statistics for today.
And what did you get? 15?
15.188.
Okay. 15. I was like, I'm not getting the same answer either, but I was doing a 102.54. I was just keeping my mouth shut until you figured it out.
Yeah. I guess we're all just a little
Yes.
done with
Okay, so then we have the 15.188, and then to figure out x, we take what? I can't remember now. 120.54 times 1.2. We got rid of the 0.126, right?
Yeah. Well, no, you did. I don't understand what you're saying.
So from there, how did we figure out what x was?
Okay, so you multiply you'd want to get the 120.54 out of the denominator.
Okay.
So you multiply both sides by 120.54. And so your final equation is going to be 120.54 times 0.126 is equal to x minus 542.3, since it canceled out on that side.
So what score did you come up with?
557.488, right, Eddie?
Yeah.
557.488.
Yeah.
But I don't understand why it says only one score, because there's two scores.
What do you mean 2 scores?
Yeah, because that's for the positive.
Oh, well, yeah. But the 90, the 10th, so it's the negative. Huh.
And when you do it for the negative, you get a 527.11.
Well, it's asking for the 10th percentile, so it's probably the 527 one. Because the 90th percentile, isn't that on the other side where the maximum is, whereas the 10th percentile is on the
Because I think they're in the middle.
minimum?
Percentile's in the middle, right? Because that's what we highlighted.
I don't know.
I'm no help right now.
Me either.
I don't know, guys. I'm just like, ah.
So I think what that means is the 10th percentile would be anywhere for anyone who scores 557.49 and a 527.11.
Because it's asking for a score. So I would say that the 10th percentile, you click on the left.
Where'd Eddie go?
I don't know. Guys, this sucks.
Yeah, all of a sudden it got like, I'm crazy confused right now.
These last 2 sections,
Everything else is like so clear until you get
I need
to
to learn how to do the math for these. Well, it's like they've taken these questions and then they've like, okay, here's everything that you possibly could have learned, and you have to take it off of this, all this info.
Yeah, it's like.
And figure out, well, the problem is just knowing what to do.
Well, it gets even more confusing when it's telling you to find the first quartile and the third quartile. Does that now we go into SPSS?
I don't know. Hey guys, if we get 23 out of, oh, just kidding. We'd only get like 19 out of the 32, right? 19 divided by 32. That means we have a 59% on this homework assignment right now.
Yikes.
So gay.
No?
Well, do you want to meet? You want to try and take this away and do some more on our own and try and figure it out and come back and do another recording?
Do you guys want to do it like, I'd be more than happy to do it like later on today or tomorrow.
Okay. I can't do tomorrow. Actually, I don't work tomorrow now that I think of it.
But that way we can kind of like do some research and like figure out really what it's asking, or even get a hold of the TA so that we learn this right instead of running in circles.
Yeah, I'm going to post this video so that we technically already did it.
Yeah.
And on it, because she always comments right after, I'm going to be like, hey, we really need help on the last 2 sections of the homework.
Yeah.
Yeah.
I agree.
Totally.
Okay.
I don't think that it's going to do us any good if we keep trying to figure out wrong, because then we're going to remember wrong formulas and recall wrong information.
Yeah.
So we really need to like figure it out so that we can help each other learn these formulas.
And then at least the quiz, the group quiz, isn't due until tomorrow night.
Yeah, so.
So what's your availability tomorrow?
I am out of class at 11:15, and I don't work tomorrow. I have the day off, so.
Okay, you guys, I'm really flexible, so you guys figure out what's best for you, and I'll just be there.
I'm
Okay.
looking at my schedule. Oh.
Can you meet tomorrow, Eddie?
Yeah, I'm good.
So
And
you
what
get
about our new person that's supposed to be in our group?
Oh,
Yeah.
she's not in our group anymore.
Oh,
Yeah,
she's
the
not?
teacher emailed us.
Oh.
Okay, so I am available between 11 and 2. I have to take my kids to the doctor's appointment at 2:15.
Okay.
So what if we met like at another, like at noon or 12:30 or something like that?
Okay. I mean, if you guys can meet tonight and we can all figure it out before then, that'd be nice too.
Well, let's do this. Let's work on it, and if someone figures it out or they feel confident, let's text each other and say
Yeah.
I figured it out, and if we're available. If not, then we can at least video it and email the video to everybody.
All right. Sounds good.
Then we don't have to worry if everyone can be there, because if they can listen to the video, that will be the best way, I think.
I'll
Yeah.
totally rewatch a video if I'm not able to meet.
I think I might even watch someone else's videos that they post.
Oh, yeah.
That's
So-
a good idea. Go to these specific spots. That's totally a good idea, Catherine.
Yeah. So I'm gonna watch those, and then I'll let you guys. I'll write it all down, and then let you guys know.
Okay, perfect.
That would be awesome.
All right.
All right. Thanks, you guys.
All right.
See ya. Bye.
Bye.